Let's deal with our next topic, which is learning about different types of structures. Uh, this little cartoon by Rube Goldberg gives us an idea of how crazy and complex structures can be. So in this Rube Goldberg structure, what happens is he comes up with several parts to the structure. So there's a man here and he slips on a banana peel, and that causes the rake to flip up and the horseshoe goes flying onto here. It presses down on the string, which pulls down on the watering can. The watering can waters this mop, and the mop is on a stand here which starts to wobble back and forth, and when it does, that causes the window to be washed. And what are the chances, or what's the likelihood that this design or this method actually washed the window? Pretty slim. There's so much that can go wrong with the complexity of his window washing device. Which leads me to an important point about building structures, and that is simple is usually best. So take the paper clip, for example. The paper clip has been designed and used due to the simplicity of its shape. It hasn't been changed much over the years. However, because it is so simplistic in shape, the paper clip could be used for so many other things. For example, it could be used to pick a lock. The paper clip, if you move it around, it could make an inexpensive ring. The paper clip could be used as a weapon if we had to, and so on. So when building and designing structures, the shape of the things and how they're arranged, which is what we call the design, sometimes simple is best for the structure to perform more than one function. So shape follows function. So the shape of an object or structure usually determines the function. The more complicated the design, the greater chance it may not perform its function necessary, like Rube Goldberg's machines. So this lesson is about different shapes of structures. And so when you look here at these two different pages, you can see that the shape of a structure sometimes isn't something that we creatively come up with. In most cases, man-made structures, which we call manufactured, come from ideas in nature. So where do we get the ideas for the design of man-made structures? We get them from nature. So let's look at this page. We have 1, 2, 3, 4, 5, 6 different structures. Some are natural and some are man-made. If you notice, they usually match up. Where did we get the idea, for example, to design an airplane, which is M for manufactured? We got it from birds and bats. So the natural structure gave rise to the man-made structure. Next, these are flippers. And where did we get the idea of the design for flippers, their shape and how the shape's put together? We got it from nature, duck's feet. So the natural structure gave rise to the manufactured structure. Egg cartons, man-made structure. Where did we get the idea? Nature. So that matching system might hold true for you when it's time for you to build your own structure. Let's use these two pages, page 1 and page 2, to see if we can see this whole combination again. Let's take the door hinge, which is M for manufactured. Where did we get the idea to build a door hinge? From our arms, our elbows. Natural, manufactured. Umbrella, man-made. Where did we get the idea for an umbrella? Believe it or not, we got it from nature, the mushroom and the umbrella. Coat hanger, manufactured. What in nature gave us the idea for a coat hanger? That's right, trees, tree branches, which are natural. Manufactured, fishing net. Where did we get the idea? Nature, cobwebs or spider webs. Dandelion seed, which floats in the air, that's from nature. What was invented as a consequence? A parachute, manufactured. And finally, in nature, we have flowers. What man-made structure did we copy from nature? Satellite dishes, so manufactured. So one way we design structures is we often ask if nature has built something with a similar function. A second way that we can group and categorize structures has to do with these categories. Structures might be put into three other categories. Some are frame, some are shell, which means they're hollow inside, and some are mass structures or solid. So here are some examples of two shell structures. This would be a shell structure, and once the chick is out of here, it would be a shell structure. Here's a frame, the Epcot. A bike is a frame structure. And a solid structure, you couldn't get inside it. So let's see if we can classify these as natural or manufactured, and then frame, shell, or mass. The skeleton of a dinosaur is natural. Okay, is it frame, shell, or mass? It's frame. Good job. This big, huge tower where you can walk through steps are inside and you will go to the top to look out. Is it natural or manufactured? It's man-made, so it's manufactured. Is it frame, shell, or solid? It is frame. Sorry, not frame, it is shell because inside's hollowish. How about this big Hoover Dam? Man-made, so it's manufactured. F, S, or mass? It is mostly solid, so it's a mass structure. A tree, well, it depends. The top of the tree, where birds can live and so on. In general, the tree is natural, and then this top part would be shell. The bottom part would be solid or mass. A shoe, that's easy. M for manufactured, and S for shell. And the Eiffel Tower, M for manufactured, and F for frame. So these are two ways that we group structures. They're either natural or manufactured, whereby usually a lot of times the manufactured gets its idea from nature, and then they're frame, shell, or solid mass. Let's review. So a student was studying, and the teacher had different models used in class to identify different kinds of structures. When the teacher made a tent-like position with the hands, the student remembered it must be, if it's a tent, well, it's manufactured, but that's not our choice. So what is a tent? A tent is like a shell, so it would be B. Piling materials into particular shape or design makes a solid structure. The following are examples of natural solid structures from nature. Natural solid. D. Mountains and coral reefs are natural solids. Brick walls and coral reefs don't work because the brick walls are manufactured. A dam is manufactured. Ice sculptures are manufactured, and so are sand castles. So the only one that comes from nature and is solid throughout is D. A frame structure, like your skeleton, is made of very strong materials so they can support the bones of our body, our skeleton, help support and hold up our organs. Egg cartons, food cans, bottles, and pipes are examples of. Are they all man-made? Shell, an egg carton, a food can, bottle, pipe. They're all, once they're empty, they're all hollow inside. Are they natural? No. Are they man-made frame? No. Bottles aren't frames, so I would say they're A, manufactured shell. Spider webs can hold 4,000 times their weight. What is a spider web? It is frame, a spider web's frame, and it's natural, so D. All the following are structures that can be classified as manufactured except what? C, a feather comes from nature. Okay, each manufactured structure can be paired with a natural structure. So let's see, only one of the pairings is correct. Which one? So does 6, 1 is flippers, 2 is egg carton, 6 is webbed feet. Does it match with number 1, the flippers? Is that a correct pairing? Yeah. Let's double check. 3 is umbrella. Does it match with 6? No, 6 is web feet. 6 web feet and 5 mushroom. No. 2, which is the honeycomb or the egg carton, and 6 the web feet. No, so the pairing is this. The standard unit measurement of force was based on what? What do we measure force in? Newton. Identify which structure would have the greatest stability because of its center of gravity. Unfortunately, I didn't draw the structures here, so don't worry about it. Which of the following is symmetrical? So that means when we cut it in half, the left and the right are identical. Not that one. Left and right aren't the same. How about that one? Left and right, are they the same? Mirror images? Yeah, let's double check. This one, left and right the same? No. Let's cut this one in half. No, left and right aren't the same. So this is symmetrical. A dynamic load on this train bridge is, so dynamic or live load means it's always changing. It's not part of the structure. So that would be the train. Engineers, they take 2 conditions into account: what the bridge is crossing and what kinds of loads to decide which type of bridge. So which type of bridge would engineers suggest to withstand very, very heavy loads? A truss bridge. And that's it. I hope you enjoyed this topic.